Hi, this is Jim Harris, and I'm at the Semico Technology Outlook conference in San Jose, and I'm talking to Jay Cormier. I said it right, didn't I?
Perfect, Jim.
Good. From Teridian, and he is involved with the energy measurement business. Can you tell us a little bit?
Teridian's a fabulous semiconductor manufacturer, and we manufacture chips like everyone else here. Mm-hmm. And these are energy measurement chips. It has its roots in smart metering. So these are the chips that would go into the smart meter, utility meter outside your house. And we're extending that into the broader home and enterprise market. Okay. So we're bringing that same accuracy and dynamic range in our metering chips into applications like white goods, power supplies for servers, home automation, smart plugs, you name it. There's lots of places where people want to measure their energy.
So now if I'm making, if I'm making a server, I can integrate your chip in there and be able to monitor the energy of that server all the time. And
that's right, because today, although in a server they measure many DC loads, they don't understand how accurate or how much AC power they're using. So they therefore can't measure efficiency. They need to measure the AC power just as accurately as the DC power.
Good. So that'll give an idea of where the energy is going in the data center.
Exactly.
Plus, if there's a problem with the device, it would show up based on that.
Yeah, we measure more than just power. We measure power factor. So power factor is another diagnostic you can use to measure, in some sense, the health of that power supply.
And for an industrial piece of equipment, it might be useful for that as well.
Exactly. Same analogy. Or even a light bulb, perhaps.
A light bulb?
Well, so if you look at some like compact fluorescents, they, their power factor is extremely low. If that power factor changes, that might be an early indicator of degradation.
Okay. Yeah, I think somebody was talking about street lighting and how having a monitor in that, a wireless monitor, where they could pick up.
Street lighting is a great example where there's really no incentive today in the U.S. to save energy because municipalities get charged on a per pole basis by the utility.
Right.
So there's no metering, there's no way to measure how much they're using, and so they don't get paid or charged based on their usage. Now, if there's a way to charge for usage, measuring how much you use, then communicate it through, as you said, perhaps an RF comms link, now there's some real incentive to save power.
Ah, that's a good thing. So tell us a little bit about your chip then.
Well, the chip is essentially, it's a mixed signal SoC. It's got a 22-bit sigma delta front end. So we bring the same level of accuracy and dynamic range that we do in our smart metering product line. And then it also has a dedicated, what we call compute engine. So it's a hardwired DSP that does all the algorithm. And then a back-end 8051 type of microcontroller, just for housekeeping functions. So that way we can segregate the metrology from the housekeeping.
So 22 bits, is it really 22 bit plus or minus what?
It's really 22 bits.
Wow.
But the important thing is to be able to get accuracy, like in the metering world, down to 0.1%.
You need that much.
So you need that type of accuracy, but you also need it over a wide dynamic range, hence why you need the greater resolution.
And this will work with different sensors?
Yes, so we commonly, the two most common type of sensors are like a shunt or a CT, current transformer. It works with both of those.
Okay.
And just last week we introduced another proprietary sensor that it works with as well.
Oh, really?
Yep, to really bring down the cost of that front-end sensor.
Okay. So this is Teridian, Teridian, and the website must be?
Yeah, Teridian.com.
That'll work. Thanks very much.
Very good. Thank you, Jim.